Hey, Pastor, doesn't science disprove the Bible?
Isn't Genesis just a fairy tale?
Is God for real? Did he really create everything in 6 literal days?
Didn't God just use the Big Bang?
Why is there death and suffering? Really believe the Bible?
Didn't man evolve from apes?
For answers to these questions and more, stand by for Believing the Bible.
Professor, what do they use to make blimps float?
Helium is the element most commonly used to give airships their positive buoyancy. Helium is such a light and slippery molecule that it will leak out of whatever contains it so that it rises above the heavier gaseous atmospheric components and eventually floats away into space.
Why wouldn't gravity keep it from doing that?
Because the pressure each of the helium molecules exerts on each other and everything around it is greater than the pull of gravity.
Cool. So what is gravity anyway?
That's an interesting question, Gilligan. You see, we really don't know what gravity is, but we know that the larger the mass of an object, the stronger the pull of gravity it exerts. However, gravity's pull is less than the pressure of helium molecules against each other.
That's weird. So how did stuff like stars and planets form?
To answer that, we need to go back to the very beginning of the universe. There was a Big Bang that released all the energy and matter we have today. Initially, all matter was hydrogen or perhaps helium or lithium, but it was very hot. As it cooled, swirling gas clouds formed. Over millions of years, the gas molecules started sticking together and eventually became the stars, planets, asteroids, comets, and various other heavenly bodies.
Oh, hey, wait a minute, Professor. Didn't you say that gas pressure is greater than gravity?
Well, yes, I did.
But that doesn't make sense. I mean, if gas pressure is greater than gravity, then how did the gas molecules start sticking together?
Don't worry, little buddy. It doesn't have to make sense to us. We have scientists who explain these things. Right, Professor? Skipper, I'm afraid Gilligan has a point. His interpretation of the nebular hypothesis, which I was explaining, brings about a very valid and scientifically supportable conclusion that negates the hypothesis.
I did? Gee, I didn't even understand what you just said.
Welcome to Believing the Bible. This is Scott Lane with Terry Reed, Dr. Daniel Harris, and our producer Ed Salzadell, all directors at the San Antonio Bible-Based Science Association. We are here to reassure you can believe the Bible from the very first verse. We've got that skit that's going to focus us today upon the nebular hypothesis. There was a discussion in there. What we're going to focus upon today is what science doesn't know that they try to kind of claim they do know. Example, the statement was, we really don't know what gravity is. Daniel, do we specifically know what gravity is?
Scientists think they know what gravity is, but that's one of the facts in the history of science is that frequently we think we know something which we don't. And that's been something that's been repeated over and over again in the history of science, that frequently we think we know something and that we don't. They said that Newton understood gravity. He claimed that it was a pull. There were other people that said it was a push. And then along comes Einstein, who says that it's not a pull or a push, it is a warping of space-time, in which he combines space and time together, because he says that the speed of light is a universal, unchanging constant. And then, in his second theory of relativity, he makes a physics which requires the speed of light to be variable, which contradicts his earlier work. All of this is quite uncertain. All of this, they say that they can do experimental observations of neutron stars colliding with each other, producing gravity waves, and the LIGO experiment is supposed to be detecting those. I'm very skeptical of all of that. Gravity seems to be one of the great mysteries of our time, and I think that it won't be until we understand the connection between electromagnetism and gravity that we actually understand what gravity really is.
Now that leads into what we really want to talk about here. That is the formation of our solar system and the interactions there. One of the things that was brought out during that skit is that gravity, we think of gravity as being huge because we're sitting on top of a huge terrestrial ball. But in truth, gravity is a relatively weak force.
It is the weakest of the forces.
The weakest of the four primary nuclear forces, and is 40 times less powerful than the vapor pressure of hydrogen gas. And that
Well, that depends upon the temperature.
It depends upon the temperature, that's true. The point is, knowing that, should hydrogen atoms ever come together to form rocks, asteroids, planets, and stars?
Hydrogen never forms rocks. It only forms gas or liquefied gas. And the point is that you can't bring things together by gravity if they have a decent vapor pressure, as you were saying. And pretty much all of space that we know of has temperatures where the vapor pressure of hydrogen and helium are sufficient to keep the gas from condensing. They say that the only way that you can get these gas clouds that we observe to condense is for a supernova shock wave to come through and push the stuff together. The problem with that is it requires a star to make the shock wave. And so how do you get the first star, in order to make the star that gives you the shock wave? So it's a real problem for astronomers. One of the things that I like to do is I like to talk about what we have observed. And we have looked into the darkest of the dust and gas clouds, the ones where the starlight from the outside doesn't penetrate at all. And we find inside those objects that they're stable. They're not collapsing to produce stars at all. The general situation is that the pressure is sufficient to maintain the status of the cloud. They're not collapsing. We've only been able to do this for the last 30 or 40 years using what's called far infrared and millimeter wave astronomy. And we've been able to look at the interior of these very, 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 very dark clouds. And they're supposed to be the place where the stars are forming. Yes, there are hot stars in there. The problem is, as I recognized long ago, is that the stars are throwing off gas. And if you actually study the rate at which the stars are throwing off gas, it looks like the clouds are a result of the stars, not the other way around.
Very interesting stuff. It also should be noted that in all those places where there's supposedly these stellar incubators, we have never seen a spot in which a star appeared. We have not seen an actual formation of a star. And we're going to hold that discussion until after the break. You are listening to Believing the Bible. This is Scott Lane with Terry Reed, Dr. Daniel Harris, and our producer, Ed Salzado. If you would like to learn more, go to sabsa.org. That is sabbsa.org. We're talking today about the nebular hypothesis. Is the formation of our Earth, the Sun, our solar system, simply a random, accidental event of nature? Terry, what do you think of when you hear this?
If I push the trash down in the trash can, I can compress the trash together and make more room in the trash can. But the trash can contains the trash and keeps it from scattering. It is the same way with a bicycle pump. If you're pushing down on a piston, which compresses the air that is in the cylinder, it forces it through a small tube. Without the cylinder containing the air, pushing a piston through the air would just scatter the air in all directions. Shock from an exploding star would be coming from one direction, and there's no container in space containing the gases. And I think it would tend to scatter the gases, not compress them together. This is science based on my experimentation and observation. And something else I was wondering, would debris from a collision collecting together form such a nice spherical shape as the moon?
Well, one of the things, and I'm going to refer this back to Dr. Harris in just a moment, is that when we do computer models, programming in what we know about gravity, what we know about hydrogen gas, what we know about dust particles, is that when you do computer simulations, what they think was an early rotating mass of gas and dust, et cetera, that was the early solar system, is that you can form up to just about dust bunnies, but then collisions of the dust bunnies go to the point of breaking everything up. You will never get to the point of rocks, asteroids, planets, and stars. Dr. Harris, you want to comment about that?
Well, it's a little bit bigger than dust bunnies, but it's not much. The idea that these things stick together is dependent upon the idea that rocks are soft when they're hot. And this is supposed to be all happening at a very high temperature. The rock material, the silicon oxides and the magnesium oxides and all the other oxides are condensing out because they have the ability to solidify at temperatures on the order of several thousand degrees Celsius. Well, at that point, yes, they are gooey and they stick together. The problem is that when these things start sticking together, they form clumps. And when they form clumps, it makes the space between them open, and so the heat can get out. The heat from the nebula escapes very rapidly when this condensation starts to occur. That makes the nebula transparent to the heat that it needs to stay warm. Well, when it cools off quickly, what happens to the rocks? They become brittle. And when they become brittle, when they collide, they shatter. So it turns out in practice, the computer simulations say that the largest things that you're likely to get are the size of a football or a basketball. Not a dust bunny, but a football or a basketball. And that's still far from a planet. So Kuiper, the great master of all this nonsense, in the mid-1900s, argued that it had to be that gravity was the thing that would then collapse these football-shaped type things and collapse them into planets. The problem is that the gravity has not done it thus far because it didn't make them collapse at that point. So why does it suddenly change its ability to collapse them into a planet after these things have condensed? It doesn't work. The gravity does not overcome the problem of these things having their own random velocities in relationship to each other. Their velocities will cause to diffuse rather than condense into a single large body.
The bottom line of this whole discussion is that we cannot find a naturalistic way for all of this to occur. And the best explanation is exactly what we find in the Bible. God created.
Hey, San Antonio. In 10 days, we will have a special presentation of the film The Star of Bethlehem and a discussion on what the star really was and its meaning. That's Tuesday, December 9 at 7 p.m. at Faith Lutheran. Go to sapsa.org for more details.
Information for creation events in our area are on our website's calendar page. For more information or to schedule a presentation, go to sapsa.org or call 210-599-7240. When you go to our website, you can click on a link to our newsletter. Our website has a link for contact information on which you can order our newsletter to be emailed to you, or you can call us. Also go to whyshouldyoubelieve.com. That is Terry's website containing articles looking at current day issues from a biblical perspective. SAPSA meets the second Tuesday of each month at 7 p.m. We are now meeting at Faith Lutheran Church, just south of the corner of Jones-Maltzberger and Thousand Oaks. There you will find biblical apologetics and creation science teaching found nowhere else in Bexar County, as well as the availability of books and videos on these important subjects. If you miss any part of this show, you can listen to the show anytime by going to the AM 630 KSLR, the Word in South Texas website. Click on KSLR Podcast, scroll down until you find Believing the Bible. Please join us again next Saturday for Believing the Bible. I'm Scott Lane, and for Terry Reed, Dr. Carl Williams, and Ed Saltville, thanks for listening, and we hope you found today a reason to believe the Bible.